Hello, everyone. My name is Sommer Panage, and I am currently the lead iOS engineer at a small startup in San Francisco called Chorus Fitness. It's a huge honor to be here today, and thank you so much for having me. So being at a small startup, I got the joy of building our app from scratch in Swift. Though I'd written lots of small side projects in Swift, this was the first time I really got to build a production-sized product in the new language, rather than Objective-C. I was so excited. I got to come up with my own app architecture, develop my own patterns. I could finally write a big app the way that I wanted to. A lot of the decisions I was able to make up front. But sometimes, as I was coding, I started to notice patterns arising. Patterns that perhaps I hadn't really planned for. And I'd find myself writing the same code over and over and over again. And I would find these patterns all over the app. And though often these little patterns would be UI related, since the UI often seems to be the most redundant code we write, I would actually end up finding them everywhere. So today what I'd like to do is I'd like to tell you 4 little stories about 4 of those patterns that I found and how I discovered fun ways to improve upon them using the features of the Swift language itself. Essentially, how the Swift language helps us write better code. I'm also going to focus on some small libraries that harness those features. Before I dive in, though, I'd like to show you the demo app that I'll be using throughout this talk to illustrate my points. It's a very simple application that uses the Star Wars REST API to load a list of Star Wars films. The Star Wars API, or SWAPI, is the world's first quantified and programmatically accessible data source for all of the data from the Star Wars canon universe. When I tap on a Star Wars film, we will get to see the opening text from, let's go back, there we go. When I tap on the data, or the Star Wars film, I'll get to see the opening text called the crawl. This is the very famous yellow text that we always see at the beginning of a Star Wars film. So as you can see, this is a really simple application, but this is all we need to illustrate the points. All right. And now I'd like to dive into the first story, or our first tale, and I call this story Schrodinger's Result. Oh. So if there is one pattern that is tried and true in everyone's apps, it's getting our data from the back end. And here is some pretty standard data-getting code that you've probably all written at some point. I request my data. If I get it back, then I send it back in my completion block. If I don't get the data, or if there's some issue parsing it, maybe it's not shaped like I'm expecting, then I call the completion block with nil for my data and an error. I'm sure we've all written this code many, many times. Now, in theory, 2 things can happen, right? I either get a result from my server, or there's some kind of an error. But if we look at the code here, that's not really the case. We see there are 4 possible outcomes here, 2 of which don't really make a lot of sense. We can, of course, get back data from our backend. Those would be our Star Wars movies. Or we can get an error from our backend. But we can also get back, in theory, our data and an error, or we could just get nothing. And that's not really what we want happening. We just want the 2 cases that we are expecting. We shouldn't even have to handle these other 2 silly cases. They don't really make sense. So what do? Well, we model our server interaction as it actually is, either a success and thus a result object, or a failure and thus an error object. It's one or the other. So this awesome little framework by Rob Ricks is the way that I like to do that. It's very simple, tiny little bit of code, and it captures exactly what we're trying to do here. And this is precisely a great time to point out that this is the perfect use case for our first Swift feature we're going to talk about, the enum with associated values. So we have 2 possible enum cases, success or failure. For success, we have a non-optional result object of type T, so that's whatever our data is going to be. And for failure, we have a non-optional error object. So now, if we go back to my code and take a look, we'll see that there are now only 2 cases to deal with. So here's my server interaction code one more time. and I'm only able to pass success or failure in my completion block. There's no other options. There's no way I can pass success and failure, nothing like that. Films is required for success, and an API error, which is my own type, is required for failure. Also, the result framework does a great job of providing some handy functional helpers to make splitting things into success and failure even faster. So once again, we're harnessing more of what makes Swift great. With, for example, the attempt function, I can simply pass a block that throws, and I get a result of the correct type based on how that block is executed. So now that we've changed how we interact with our backend using the result framework, we can go back to my view controller and look at the code again. All of a sudden, it makes so much more sense. I say API client, get films, and then I switch. Result is success or failure. Success, I show my UI. Failure, I show my error UI. That's it. So what's the moral of our story? Using the result enum allowed us to model success and failure from our server interaction more correctly. And this allowed us to simplify our view controller code. That sounds like a huge win to me. So now that you're talking to your backend, you're getting your results from your backend, it's very likely you're going to want to display this stuff, right? So as soon as we start talking about displaying things, we have to think about layout. How are we going to lay out our views? In this next short tale, I'd like to talk about my favorite Swifty way to work with auto layout. Now, before we jump aboard our auto layout train, I want to talk about a few different ways of doing layout, because obviously it doesn't have to be auto layout. Of course, there's the old school way. This is layout subviews. But we all know that when we want to start supporting multiple device sizes and rotation, all of a sudden, even a moderately complex layout becomes nearly impossible because, it just balloons in your huge layout subview method. Now, of course, there are storyboards and nibs. Now, we could use up this entire talk discussing whether or not you should use storyboards in your production apps, but that's not what today is about. I recognize that there are a ton of benefits to using storyboards, but I just want to quickly explain why I generally don't use them in my production apps. Firstly, working on teams is much harder with storyboards in my experience. When you have to do a code review, you're code reviewing an XML diff, and that can be annoying at best. Changes are not always super obvious, and even worse, when there's a merge conflict, resolving them can be a pain, just like with your Xcode project files. Next, you know how when you're dealing with a UI, you're often repeating the same colors and fonts and margins over and over throughout your app? Well, those values should all be decomposed as constants. But in storyboards, there's really no built-in support for those constants. So every time you reference color hex C645DF, it's a unique reference. And if that changes, you'll have to change it everywhere. Another issue that I have with storyboards in production is the fact that view controller IDs and segues are identified by strings. Now, if there's one thing we love about Swift, or at least I love about Swift, it's that it's a strongly typed language. So why waste that feature and have stringly typed view controllers and segues? Now, for those of you who, if you are still using storyboards, I will note here there are some code generation tools that do help with this issue. So that is one issue you can work around, but you do have to pull in some outside help to do it. Finally, going back to storyboards, the connections between our interface builder files and our outlets in our code are not enforced at compile time. So if I draw a connection between my button and my tap button method, and then I rename that method, my project will still build, but I'm going to crash at runtime. So anyway, that was just a quick detour to kind of explain why I wanted to focus on programmatic auto layout in this talk. So if I'm not using storyboards, like I said, we're going with programmatic auto layout. In my little Star Wars app, we can see that the main view is a table view, and that table view is the same size as its parent. Now the code here on the screen shows how I can use iOS 9's layout anchors to set up that layout. As you can see, it's a bit verbose, but it works. Still, what bothers me about this code is that it's not really clear by looking at it what the layout is. I have to read 5 lines, and it still might not be completely obvious. And since this layout is really simple, it shouldn't be that hard. To make this code far more readable and far simpler to write, I like to use another framework called Cartography by Rob Bunke. In my opinion, cartography makes auto layout function the way that I had always dreamed it would back when it first came out. Using cartography, you can set up your auto layout constraints in beautifully declarative code. And it's particularly Swifty because we're taking advantage of another powerful Swift feature. In this case, operator overloads. If we look at this code, we're stating clearly and exactly what we want. The table view's edges are equal to the parent view's edges. That's it. Those are my constraints, and I'm done. Now, here we see a slightly more complex example of a layout with cartography. This is the layout for our little movie cells in our Star Wars app. The lovely thing here is that we can just look at these equations and pretty quickly understand exactly what's going on, because essentially we're expressing our auto layout as a set of linear equations. So if we take a look at our code, we see that our episode number has some margin within the content view. Our title has some padding, offsetting it from the margin, and it's centered on the episode. So again, we get to just read through the code and we can actually kind of understand what the layout is, which is really, I think, the best thing about doing auto layout in code. So the moral of the story, using the cartography framework harnesses a great feature of Swift, operator overloads, and it makes programmatic auto layout a breeze. Now, once you've done your basic layout work, it's time to look at the different states your data may be in the view that you're presenting. Often, we find that our views have their data in at least 3 states, and I'm going to focus on those main 3 states now. The data is either loading, or the data has successfully loaded, or if there was some type of an error, then we're going to have some kind of a UI state that expresses that error. So now if we go back to our Star Wars app, we'll actually get to see that these 3 states indeed exist. So here we see, of course, our loading state, just like we expected, and this is our loaded state. We have data. Over here, we have our loading state, but this time our backend's not going to cooperate, and we get an error. So these are the 3 states, and these are very common in any application with a REST API. So how would we manage that? So below, right here, you'll see how we might first handle our different view states. We have some flags. It's a pretty common way to handle view states. And the flags denote is loading or is error. Now, based on setting those flags, we can either show the loading indicator, or we can show an error state, or we can show our data. And in our view controller, we just use those flags. Here we set the main view to its loading state, we make our query, and then based on success, we toggle loading off, we turn error off. If it's an error, we turn error on. Typical flag stuff. But I bet you're noticing a pattern here from an earlier part of my talk. This works, but it's not great. First of all, we are actually, again, representing more states than we have. And this does sound familiar, doesn't it? We saw this issue with our API results as well. As you can see, if is error and is loading somehow accidentally get set to true, we don't really know what state we're in. Is it error? Is it loading? I'm not really sure. Another problem with this flag approach is that we can set our data independently of our flags. So that means if we have data, but somehow we maybe toggle the flag on when we shouldn't have, we could easily be showing the wrong state. We should only have data when there are no flags set. So let's think about what we really want to represent. Our view has 3 states, and 2 of those have some associated information. So once again, this harkens back to something we've done before, but this time at the UI level. This is an enum with associated values. Here we can see our main view now specifies exactly what it needs. It's either A, loading, and it needs nothing. B, it's loaded, and it needs non-optional data, which would be our movies. Or C, it's in some kind of an error state, and it takes an error message that view can then decide how it's appropriate to show to the user. Notice that we can also initialize our view with the exact state we want. So from initialization forward, our view is always in exactly one state. Now, in our view code, we use a switch statement in the did set block for our state variable to put our view into the right visual state. All of our view management happens here and nowhere else in the view. Nowhere else in our code do we need to change the show or the hide, and everything is in one easy-to-manage place with this switch statement. Now, finally, this simplifies our view controller code as well. We set our view state to loading before we call getFilms, and then we set it either to loaded or error depending on the result. And that's it. So, what's the moral of the story? By modeling our view state with an enum with associated values, we're able to simplify our view controller code. We never end up in an ambiguous view state, and we centralize our view logic into one place in our view. Now, we have definitely improved our code a lot, but we can take this view state management one step farther. If we watch the video of the app again, we see that our second view controller, the one that shows the famous yellow text, it also seems to have the exact same 3 view states. And in fact, as my app grows and I start showing all different things about the Star Wars film, every single view is going to have those exact same 3 states because I'm going to be hitting an endpoint, loading, and either showing results or an error. And this brings us to our fourth and final tale I call Pete and the repeated code. With our current approach, we'd have to repeat the whole show hide dance for our error and loading views in our opening crawl view controller. And it would be nice if we could just say, hey, this view always does the same things in the same 3 states. Then all we'd have to do is provide the different views and some other things that some other basic implementations, and we would go ahead and do all the showing and the hiding for us. So what we have here, we have a set of behaviors that we want to be shared by unrelated objects. In this case, our unrelated objects are our main view controller and our crawl view controller. So this is the perfect time to think about using a protocol. A protocol defines a blueprint of methods, properties, and other requirements that suit a particular task or piece of functionality. The protocol can be adopted by a class or a struct or an enum, and it can provide an actual implementation for those requirements. In this case, we want to represent the behaviors associated with having 3 view states. So what does our protocol need to describe? Well, we want to address loading data into a view and having that data either load or fail. So in order to do that, our view needs to have a view state enum, it needs a loading view, it needs an error view, and when things change, when state changes, we need some sort of an update function to call. So we'll put those things all in our protocol, and now that we have our protocol, this is the set of behaviors that will define our loading pattern. Now, since anything can use our protocol, we'll go ahead and we'll make our view state enum that we saw before generic. So now it doesn't have to just load movie items, it could load text for our crawl, it could load a list of characters if we decide to expand the app, it can load whatever it needs to. So now what we want to do is this. We want to say if any view conforms to our data loading protocol, it should show and hide the loading and error views appropriately. In other words, what we want is a default implementation of our update function, since we know that the update behavior is going to be the same for all of our different views. So we can make an extension on our protocol and provide that default implementation whenever the conforming object is of some class. So in this case, what we do is we say, hey, if I'm a view, then this is what I do if update is called. Now, no view needs to implement update if it doesn't need custom behavior. So to review, any view that wants to load data in our standard way needs to conform to this protocol by doing 4 things. It needs to provide an error view. It needs to provide a loading view. It needs to provide a state variable that can be set. And it needs to call update at the right time. So if we go back to our main view and now have it implement our loading protocol, all of a sudden, a whole bunch of code goes away. It provides the necessary views, it provides the state, and it calls update when we set the state. And that's it. If we jump to our crawl view, we see the exact same pattern. Indeed, any view in our app that wants to do a loading behavior will have this exact same pattern. We have just a tiny bit of repeated code now, but all of the real business logic is up in that default implementation, and we don't have to deal with it. So what's the moral of our fourth story? By decomposing functionality that is shared by non-related objects into a protocol, this helps us avoid duplicated code and to consolidate our logic in all one place. And that's the end of the fourth tale. So let's review what we've seen so far. By using result and enum with associated values, we can easily differentiate how we manipulate our data and our errors. Cartography gave us a great example of how operator overloading can make auto layout code much more readable. We saw that by using view state enums, we can easily put all of our view manipulating code in one place, and we can avoid bugs in our view state. We can also simplify our view controllers since they now just need to declare the correct state. And finally, we saw that by using a bit of protocol-oriented programming, we can avoid duplicating code when our views have shared functionality, as they often do. And so that's it. That concludes the 4 stories of the patterns that I observed so far as developing our new Swift app. Thank you so much for your time, and hopefully I'll get to talk to many of you during the Q&A.
Awesome talk, speakers. Awesome talk. Really appreciated it. With your views, what is it? Have you used anything apart from? Oh, sorry, right over the other side. Hi. Have you used anything else apart from enums and stuff like that to sort of create generic view controllers and stuff? Or are you just sort of focusing more on enums to allow for state?
Currently, we've been, like I said, we're using mostly the generalized enums, and that's doing most of the state management. We have pulled out functionality into some more generic view controllers as well. We have something like, for example, we look at patterns in our view controllers, and if there's a repeating pattern, a really common one is an action pattern, we call it, and we've kind of decomposed that out to take a generic action object, and then the view controller essentially populates with that. So we have definitely looked at some other approaches using generics with view controllers, but I think the enum pattern definitely has been one of the favorites because it just makes getting rid of very, very common repeated code very simple. But yeah, I would definitely say that we've explored generally more generic view controllers for common visual patterns. Does that answer your question? Cool.
Okay. Thank you, Sommer.
Thank you.